Hey everyone, Chris here again. So today we're going to look at setting up a whole bunch of functions that'll help us with the transform component and allow us to do things a lot more intuitively than working with the raw data that the transform component stores. So we're going to start off just setting up all the function prototypes here. So one of the things that I've added in here is on all my setters, you'll notice as I write them, I'm going to return the transform. And this is so that we can just have one big long chain of setting. So we can just do set rotation, set position, set scale, all in one, and we don't have to worry about it coming back. We don't have to do different lines for every one. We can just do it all in one line, and then we can space it out and stuff like that. So that's one thing. I think Ogre does that, and I was looking at that and talking to some people and using that. So the first two things we have here are we have set rotation and get rotation. Right, and that's just going to return the set the rotation by quaternion, which we probably won't be doing that often, although there may be times to do that. More likely, it's going to be this stuff, which is rotate object. So we're actually, originally I had this in 3 separate functions, but we're actually going to break this up a little better. So we're just going to call this rotate. Yeah, we'll just call this rotate, and we're going to pass in a vector3 axis. Let's got capital V there. Got some naming convention fail here for these functions, so we'll worry about fixing that later. Right now it's not that important. We're just going to call this rotate, pass in an axis, and then we're going to pass in a float, and this will be L angle. And this way we can have this working a bit better than originally we just had 3 functions, so we don't need those brackets there. That'll come later. And that'll actually cut down on the number of functions we have to write, which will be nice. We're also going to have 3 functions for getting the get right, get up, and get direction. And these are very useful when you want to move objects around the scene, because you can move them in the direction, say, that they're facing by getting direction or getting up or getting right. So it's very useful for moving objects. So we're gonna make sure we have those in there. Next, we're going to have our position. So vector3 get position, and then we're going to have a vector3 get world position, and this is so that if we have a child object and that object is and if that object is attached to an object and we just get its position, it's going to be its position relative to its parent object. However, we get world position when we write it. It's a recursive function, and it'll actually work its way all the way up the tree and then return the position from the top of the tree, the sum of all the positions in that one branch for that parent all the way up. So that's very useful to have. There are a number of reasons we'd want to have that, although none come to mind at this very moment, but I know it's important because I've used it when I was originally, because a lot of this stuff here is a lot of this math here I pulled from a previous engine I was writing for GDW last year, which is, if you don't know what that is, then you're not from UOIT, but it's basically a project where you build a game over the course of a year, or a course of 2 semesters. And so I wrote an engine for that. So next thing here is we're going to set position, and we're going to just take in a vector3 fix that capital L there. I don't want a capital L. Now we're going to have 3 overloads of a transform or translate object. And these are going to be, one is going to take in a float translation, one is going to take in a vector 3 translation, and one's going to take in 3 floats. I like providing lots of options for doing this, although really you could get away with just having a single method if I really wanted to. Alright, we're just going to copy that translate there. And we're going to copy this one more time here. X space there, and we're just going to change this to vector 3. And then we're going to go here, and we're going to have float x, float y, and float z. And that'll set those up. Now we're going to have our scale functions that manage that. So we're going to have a get scale, and this is just going to return a scale matrix. We're also going to have a float get scale x, and we're going to have the same for y and z. This really isn't terribly useful other than if I want to display this information. If I want to display this information in like an editor GUI or something like that, then I'd want to have functions like that. But it's not terribly useful to get the actual scale of an object for any reason other than seeing what it is. So user feedback for that, but you're not really going to want to do too many. I mean, there may be some reason why you want to use scale that I can't think of right now, so I'll add it in there, but that's not why I'm adding it. I'm adding it for an eventual GUI that will control things. I keep adding those in there. So now we're having a set scale, and same with the position. We're going to have 3 different types of scale here, and we're going to have a vector 3, and then we're going to have a float x, float y, and float z. And then float scale there. And that is, so float scale is probably the one you're going to use most because that's set uniform scale. The other 2 are for non-uniform scales, and you really shouldn't use them, but you can use them. So now we're going to have scale object, and what this is going to do, or rather just scale, this is actually going to, we can actually copy what we have up here. This is going to be the exact same thing, except instead of set scale, we're going to scale, and this will, what this will do, this will actually increment the scale rather than just setting the scale to a fixed value. This will increment the scale by a certain amount. So that's useful if we want to have like an object that, say, lerps over time, increases in scale, and then decreases in scale. We can just pass in negative and minus values to that. And there's Skype popping up there. So one of my classmates there. And the last things we're going to have here are we're going to have matrix 4. And it's going to be get local matrix. And we can just copy this down because we're just going to change the name of the function. Going to have get world matrix. Let's make that capital M there, as it should be. And then we're going to get the MB matrix and the MVP matrix. Alright, so that's going to be it for that. That took quite a while, so I'm going to take a quick break, check the time, and we might end off here, or we might start getting into the actual CPP file. Alright, so we have a bit of time here, so we're going to start by, well, we'll start off with the first thing, which will take a little while. We're actually going to copy all of these. Just remove that breakpoint. my fraps, which I use to record, is set to F9, which also inserts breakpoints. So every time I toggle my thing there, we get a breakpoint inserted. I should probably change that key, but I'll worry about it later. So we're going to go through, and first thing we do is this is, I copied all these over, and we're just going to paste them all down and set them all up. And then we'll go through and we'll start implementing them. First thing we'll implement though is we'll go through and we'll actually return this, or return a vector, just so that nothing breaks, and then we can fill these in as we get time, because we probably won't have time to fill these all in this video. So we're already over 10 minutes at this point, and I want to really try and keep this to 15 minutes if I can. I don't have that limit on YouTube for uploading, because you can actually bypass that limit just by going to like register your cell phone number, I think is what you have to do, which is nice that you can get around that 15-minute limit, because that 15-minute limit is kind of hard when I really don't know how long these videos are going to be. I have a plan for what I want to cover in a video, and then I cover that basically, and that's how long my video is. This time actually though, I sort of know what I have to cover, but I know I can't cover it all because it's a lot. There's a lot of functions, as you can see. It took almost 10 minutes just to write all those with me talking. Doing things by video actually takes longer. So we're going to start off here with the get rotation, and this is just going to be return this, and it's going to be this M rotation. Oh, and I forgot we also need to do this transform stuff in here to let it know what class these functions actually belong to. Later on I might rename a lot of these functions because I don't really like the names, but really you can name them with whatever you want as long as they mean something to you and to anyone using your code base. So I'll probably rename these. I tend to like capital letters on my functions, so I'll probably go through and do that. I come from a C# background. That was really, well, not the first programming language I used, but first programming language I guess I used was probably Turing or Visual Basic. But C# was definitely a language I've used a lot, and I'm really comfortable with it, and I do like a lot of the naming convention for it, although I do add a few flares, like I prefix my variable names with M underscore and such. So the next thing we're going to do here is we're going to go back up and set this this rotation, and we're just going to set it to that. And then because these are going to return the transform, we just make sure we return this. And before I forget, let's actually go through and add that to every function that has a transform as its return type, or transform pointer, and we'll just return that. And there'll still be some errors in this until we actually finish setting up all these functions, but that's okay. Having this transform here will actually make things much easier for setting bulk values, like when you want to initialize an object, and you can just set them up like that. So now we're going to do this rotate here, and this is really probably one of the longest functions that we're actually going to be writing, and it's not that long, it's 4 lines but there's a lot going on in this 4 lines. So what we do is we're going to create a new quaternion, and then we're going to pass in. Now I was actually looking at the previous code I wrote. When I pass in an axis, that's nice, but actually I think I'm going to change this because there was a reason I did this before. I had rotate around, so I'm actually going to change this back. So we're going to go back here, and we're going to change this to rotate x, rotate around x, rotate around y, and rotate around z. And the reason for this is because our up, right, and direction will change often. These are basically local rotations to the object and not world rotations. And I'll probably look at adding world rotations in, but for now we're just going to leave it with what we have here, just doing local rotations. So we're going to copy this function. I'm just going to change it. We have to adjust the header. But yes, so these will only rotate. They'll rotate around the local. We might as well actually leave the other one in there and just call it rotate. We'll leave it in the header here, and we'll actually write all of them so you can see how they work. I haven't really ever played around with rotating without doing it around the local axis, at least in my own code. I've done it in things like Unity and stuff like that, but I've never really done it in this code. So I know it'll work, but it's just something I haven't done before. And this is going to be rotate, and it's going to take that axis in. And this will be, it gives us world rotations though. Alright, so let's start by doing this. So basically we're going to take the quaternion here, and we're going to call from axis angle, and we're going to pass in, for the first one, which is just the rotate, we pass in the axis, and then we're going to use math utils, and we actually need to include math utils up here. It's not included right now, and I can actually show you what math utils is. So math utils is one. It's another one of my math classes. It was here. I don't think it's actually showing up. Let me just re-add it back in. You can see everything here. There's the math utils. Right, so math utils here, it just has 2 degrees, 2 radians, and it just converts that. Then it has a clamp and a minimum and a maximum templates, as well as a lerp on a float. So that's all it has right there. Nice and simple. It's just some helper functions that I used, like this, which so you don't have to type this out every time. I also defined pi here. Down to, I'm not sure how many digits here. It's quite a few. I pulled it off Wikipedia when, I think is where I got that number from. Or sorry, no, I pulled it actually from where their own definition of MPi. I redefined MPi where I need it, rather than using the math MPi, because sometimes it can be difficult to ask. I've had trouble actually accessing it at times, so I figured why not just define it myself and not have to worry about it. So we're just going to take math utils 2 radians here, and we're going to pass in the angle. Close that off there. So the function off, and then we're going to take this rotation, M rotation, sorry, this way, M rotation, and this is going to be, well, I think I've set up the overloaded functions for this. It's going to be times equals that. No, it appears I didn't set up that overloaded function, but that's okay. We can just do it like this, and it's the same thing. So we can actually copy this down over to the others. We just want those 2 lines. We'll copy it down here, and all we're going to do here is, instead of axis, we're going to pass in this for the x. We're going to pass in the right. Go, there's M right. Then for here, we're going to pass in this M up. And then here is this M direction. And so we just pass in that like that, and we're done. And I think we're out of time here, so I'll see you later when we get around to finishing the rest of this transform class. So have a good day.